Hello all, in today's lecture we'll be seeing how to implement a half adder using NAND gate. Fine. What is the sum output of a half adder which we saw in the previous lecture? Sum output is A XOR B. And what is the carry output of a half adder? It is AB. Fine. Now let's see how to implement a half adder using NAND gate. Now, what is the sum output of a half adder that we found? For sum, the output that we have found is A XOR B, which can be written as A B bar plus A bar B. This you very well know. Fine. For implementing in a NAND gate, we have already seen in a previous lecture, in case if they are asking you to implement only using NAND gate, NAND meaning it is the complement of your product. So what does it mean? The final expression, the final circuit diagram, you can implement only if you have product terms in your expression, right? So when you check here, first term, first minterm, it is a product term, no issue with that. The second minterm is again a product term, but you have a sum term in between. When you have a sum term, you have to convert that into a product term for implementing using NAND gate. So how do you convert that? Can I write it like this? You know, A bar is 0. You very well know that. So I've just expanded it like this by using A bar equal to 0 so that I can take some common term outside. Fine. Now, from this, which is the common term here? It is A is common. So I'm going to take A outside and then the other terms I'm going to write. Here, which is common term? B is common. So I'm going to write it like this. Clear? Now, you also know AB the whole bar is equal to A bar plus B bar, as per the Boolean postulates that we have read. Now, A bar plus B bar, it is here. So, can I replace A bar plus B bar with AB the whole bar? Fine. This is what I'm going to do now. A bar plus B bar, wherever I have A bar plus B bar, I'm going to replace that term with A into B the whole bar. Clear? In a similar way, for the second term again, it is B into AB the whole bar. Is it clear? Now, when you see, this is a product term, this again is a product term, AB the whole bar, I have done a product with B. Here again, AB the whole bar, I have done a product with A. So this entire term is a product term, this again entire term is a product term. I have only one plus in between. That plus I have to convert that into a product term. How do you convert a plus into a product term? In case if there is a plus term and if you want to convert that to a product term, what you should do? A complement of a plus gives you a product term. Right? And the converse as well. In case if you have a dot, the complement of a dot will give you a sum term. Clear? When you're taking a bar, you're not supposed to take bar only for the symbol. You have to take for the entire expression. Clear? Now, expand it like. Clear? This is how I'll be replacing this plus with dot product. If you want, you can just simplify this expression to check whether we are getting the same expression or not. Clear? Let's simplify it also for you. A into AB the whole bar. If you are splitting this whole bar, it will become double bar plus B into AB the whole bar double bar. Right? Both the double bars, you know, A double bar is equal to A. So both these two bars will get cancelled out. So it will become A into AB the whole bar plus B into AB the whole bar. Have we got the same term here? So can I represent this term like this? Fine. Now, when you check here, this entire term, it is full of product terms. It doesn't have any sum term here. Right? So this is my final expression which I'll be implementing using NAND gate. Now, let's try to implement this now. How do you implement? Start with AB bar. It is AB. AB is a product term. So A input and B input. For a product term, which gate you will be using? For product term, you will be using AND gate. And for sum term, you will be using OR gate. Clear? And for NAND, complement of a product term will give you your NAND gate. In a similar way, complement of a sum term will give you your NOR gate. Clear? Now, I've got a product here and I've got a complement of a product term. So for that, you have to use a NAND gate. So I'll be giving a NAND gate. What is the output of a NAND gate? The complement of the product of your input. Whatever input is given to you, You have to take the product of it, and since you have got a bubble, wherever you find a bubble, bubble meaning you take a complement of it. Clear? Now, I've got this term. Now, for this term, I have to do a product with A. So, A is already here. So, I'll take A here, and then the output of these two terms, I have to do a product. But apart from product, there is a common bar for these two terms. So, since there is a bar, I'll put a bubble. So, what is the output of it? It is the product of your input. This input is A, this input is AB bar. AB the whole bar. Since I have got a bubble here, common bubble, it will be like this. Is it clear? Now, for this term, now we are done with this entire term. This entire term has been done. I've got this entire term output here. Clear? In a similar way, we have to do for this expression as well. For this, what AB bar, we already have it here. Clear? AB bar, you have to do a product with B. I have B here. So let me take B from here and then AB bar from here. What I have to do? I have to do a product. So I'll do a product. Product in the sense I'll be following AND gate. For product, it is AND gate. Clear? And you have a bar on top. So if you have a bar, what you should do? You should put a bubble. So what is the output of it? It will be, this is AB bar and this is B. Product of your input. It is AB dot AB bar, the whole bar, since you have a bubble here. Is it clear? Now I am done with this term also. I am done with this term, I am done with this term. These two terms, what I have done? You have to do a product. So the output of both the gates, take and give it as an input to another NAND gate. Why NAND gate? Because there is a whole bar here. Clear? To represent that bar, you will be giving a bubble here. This is your final sum. Clear? We are solving for sum. So we have got the sum here. Understood? Now, we are done with sum. You have to represent carry as well. So carry, how do you represent? It is AB. Here you have an output of AB bar. So how can you convert AB bar to AB? This output of AB, if I feed inside another AND gate, what will be the output? It is AB bar. You have a bubble here, so it will be double bar. Right? AB double bar. When you simplify, it becomes A. This is same as A double bar is equal to A. You're cancelling out both the double bars. So here again, if we cancel out both the double bars, I'll be getting it as A. So this is same as my carry. This is my sum and this is my carry. This is how you will be implementing a half adder using NAND gate. Is it clear? If they're asking you to design or implement a half adder using NAND gate, this is how you'll be doing it. Your first step has to be take out the sum, try to solve and convert all the min terms, whatever you have. See to it, it has got only product terms, because for implementing in NAND gate, your output has to be only product terms. If there is any sum term, you have to convert that into product term for implementing in NAND gate. Clear? After implementing the sum section, you have to implement the carry as well. This is your final combinational logic circuit for your half adder using NAND gate. I hope you're clear with this. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.